Hi, I'm Maya Zimmerman, or Fantastic Fox, and this is my new game, HELL³, which I'm doing a devlog right now. It's for a game jam, the Build Your Own Game Jam 2026, hosted by the Pig Squad, the Portland Indie Game Squad. And sorry, I'm gonna ramble. I haven't prepared this. I just wanted to talk about it randomly. Because I hit a point in the process where I am pretty much done. And I put out a call to people to record voice lines for it, and I've gotten a few, and I expect a few more from people who had expressed interest but hadn't sent me something yet. So it's not done. I'm not posting it yet because I'd like to get those in there. So it's not just the same. I think there's 5 voice lines currently. And so this was something that I came up with after making a previous game, not for a game jam, called Hell. Unsurprisingly, HELL³ came from Hell. And Hell was a game that I learned raycasting with, where it is pseudo 3D, all the movement is happening in 2 dimensions, but it's projected into 3. So this is actually the opposite of that, where it's moving down dimensions from the movement to what's being projected. It's moving in 4 dimensions, and it's being projected into 3 dimensions. And then again into 2 to have on your screen. So in Hell, I used a map algorithm, or a maze algorithm, to generate perfect mazes, which a perfect maze is one in which every point on it can only be reached by another point via one route. And there's no looping, obviously. Like, you can't loop because then you could reach it via another route. Every point in the maze can be reached from another point in the maze. There's no dead space where it's just something you can't access in any way. And it's really what you think about when you think about mazes, are perfect mazes. Like, anytime you've seen a maze on paper and drawn a little line through it, or just worked through it in your mind, that's almost always been a perfect maze. And in Hell, I used a maze algorithm called fractal tessellation. And it's really simple, and the results are kind of baffling, kind of beautiful, but also kind of terrible to navigate. And that was very fitting for Hell. And essentially, from a gameplay perspective, the thing that Hell has going for it is map reading. It has a map of the maze, and you don't see where you are on the map. You just see the map. So it kind of I said it got neurons firing in my brain that had been withered by GPS, because so much of our map reading now shows where you are, and that's obviously not how it used to be. You'd have a map and it would show you the locations in your general vicinity. If you're looking at the right map, it should show generally where you're at, but it doesn't show you where you are on the map. And when I started playing Hell, I was like, oh, this is like map reading, you know? Because I tried it with the player position, and it was kind of a little too easy. And then actually taking it out of there, I was like, oh, this is great. This is the game. And I put it out. It's on Picotron. It's on Itch, on my Itch. Maybe I'll toss a link in there. But when I was thinking about the algorithm and how it works, because it basically takes loops, it takes this one empty node and it copies it and the outer wall, and then connects 3 of them, but not 4. And then it keeps doing that over and over and over again. So you get these patterns of like everything's self-similar. And when I was thinking about how that works, I realized I could apply that to the 3rd dimension and make 3-dimensional maps, 3-dimensional mazes. Three-dimensional maze cubes. So I did. And the map algorithm was by far the easiest part. The maze algorithm. I came up with it in a few minutes. It didn't take very long. And actually, yeah, you can see it right here. Or maybe that won't show up. It doesn't. It seems like it's not going to show up. Anyway, oh, I can't share any of my notes. Does the cube show up? Oh, this music doesn't loop. I gotta make this music loop. Oh, there we go. That shows up. So yeah, I took several pages of notes. I swallowed that coffee wrong. I'm gonna start this just so that some music's going. So I'll have to fix that so that the title screen music loops. It's the only music that doesn't loop currently, and it should. Even though it's 8 minutes long, and you probably don't need 8 minutes to get into the game from the title screen, but if you get into it or get distracted, I would like that to be considered. So you can see now the maps. And basically, each one of those squares is a layer in the Z dimension. No, Y. So, you know, the first layer is Y is 0, the second layer is Y is 1. Oh god, those voices. So, one of the things involved in this project was free range of motion because you have to be able to move in 3 dimensions, which, yeah. So see, we can go here, and you can see the little indicator, the green indicator for the player. Yeah, I'm kind of playing my hand here. So you can, move freely in 3 dimensions. You've got, you know, pitch, yaw, and roll. Complete free motion. And ever since I got it working, I haven't had an issue with it not working. And it not working was quite a thing. Quite a thing indeed. Because free motion like that, as much as I described it with Euler angles, if you use Euler angles, if you describe your motion with Euler angles, you will encounter gimbal lock as soon as you start getting up to like pointing straight up or straight down. And that's no good. Gimbal lock, I didn't understand. I thought maybe it wouldn't be that big of a deal. I thought maybe it's not, I thought maybe I could avoid it by having it move like such that it doesn't hit exactly 90 or like, you know. I thought I could get around it with Euler angles. No. So a friend got me using quaternions, and I referenced, and I'm gonna link it. I'm definitely going to link the website that I used extensively in researching quaternions, which is Visualizing Quaternions by Ben Eater and Grant Sanderson. I don't think I could have gotten there without that website. And it's just one of my favorite websites on the internet. Like, it's so good. It's so good. It's entertaining, even if you're not struggling with math, which I was very much struggling with math. But I found a formula later on that I had calculated on my own by multiplying quaternions. I was like, well, if I multiply a quaternion by another quaternion, multiplying, you know, I times j and j times I and all that, I can get a quaternion from it because of the imaginary nature of the I, j, and k values. And I know that probably doesn't make any sense unless you're like familiar with them. So I performed that calculation on paper, and it's in my notebook. I have 22 pages, 11 pages double-sided, dedicated to HELL³ in my notebook. I performed these calculations myself without finding the formula online until after I had already done it, and I went to so many math websites, and I pretty much lived on the Visualizing Quaternions website for like a few days. And all of that was getting this camera, this free motion. You know, if you turn right, you turn right. If you turn left, you turn left. If you turn right, you turn right. If you turn up, you turn up. And if you turn down, you turn down. And you can do a barrel roll if you are so inclined. So yeah, you have free motion, free range of motion, which was hard to implement. That's basically what it comes down to. I spent days on it. I also spent days on the algorithm, which took me minutes to come up with, but implementing it was kind of a nightmare. Just because I didn't understand placing, you know, how to have the calculations work exactly. You know, is this idea in my mind, but it was actually making a program that implemented it. And I did. I got it. It took me days to do that. It took me days to get the movement. There's a lot of this project that took time. Beyond just normal making a game time. I had never used Love 2D. This is made in Love. And, you know, don't let the name Love 2D deceive you. You can do 3D. You really can. And it made me want to try 3D and Picotron, because now I understand it. Now I understand how 3D works, how to use model and view matrices and stuff like that. Like model and world matrix and all that to project a model into 3D space and then project that 3D space into 2D space. This all started because of the RPG that I'm working on, which that's my real project. I have to do something for the HELL³ soon. I'm actually getting a HELL³ possibly in the next couple of days. It should arrive. And then I'm going to be developing for that. But after that, I'm getting back to work on my real project, my most favoritist project, which is an RPG called In the Stars, In Your Eyes, and I'm working on it with my dear friend Undercat. I have a couple of other people who are involved, but Undercat and I have devoted a huge amount of time to this already. You know, over a month straight of just like grinding serious work on that RPG. No, sorry. This is supposed to be a HELL³ Devlog, not a In the Stars in Your Eyes devlog. Although I spent more time on In the Stars in Your Eyes than I did on this. But I wanted to implement some 3D, some rudimentary 3D in the Stars in Your Eyes, because I was partly because I was influenced by Suikoden, and partly because I had some ideas from a scene direction standpoint that I wanted to do that I really kind of needed some 3D for. So I started going down the rabbit hole of like, well, how do I do raycasting? How can I do these things in Picotron? And learning a little 3D kind of led to learning a lot of 3D, led to learning quaternions. All of this just kind of happened. It's been quite a journey. It's been quite a journey making this HELL³. There is an ending. There is. You can see it in the little map up there. There's a little spot in the lower right-hand corner. It works the same way as HELL. HELL had, you start in the upper left-hand corner and you go down to the lower right-hand corner. Pretty normal maze configuration there. And this is the same way. You go from the upper left-hand corner to the lower right-hand corner, except the lower right-hand corner is also separated by three-dimensional movement. So yeah, I think that's it for now. I want to get some more voices. The voices of the damned, which you've heard playing in the background this whole time. I've got a few different voice lines recorded from myself and some other people. I have some other people who said that they were going to help, and that's kind of keeping me from posting it for now. But otherwise it's done. You can get an ending, and actually, let me... So, HELL³. Oh, did I want to talk about the code? I could show off the code. It's right here. Let's dig into the code a little bit. So yeah, this is in Love 2D, which does do some 3D, and I think my computer's still doing okay considering I was running that with OBS running. Yeah, I've got a little Dorito on the title screen. What's the interesting stuff? This is probably the interesting stuff, really. Because yeah, these tables took like 24 hours of furiously scribbling notes and writing diagrams on paper to visualize. Yeah, that was that was 24 hours that I did not touch code, which I think is the only time I've done that in a game jam, was just go a day without coding anything, just straight up writing notes the whole time, trying to understand what I was trying to do. And it starts really simple. It's like, it generates a filled cube. Put a hole in the corner. And then, depending on how many iterations there are, it copies the last iteration. And it does that 7 times. 1 for, 7 more locations to give you 8 total. 2 cubed. And yeah. So yeah, it starts, the first cut is just random, and then it starts taking the silly table is every configuration of the numbers 1 to 4 in different orders. So I can toss, I do a random out of 24, and that determines the order instead of having a function that sorts 4 numbers, which I don't need a function to sort 4 numbers. I've just got this silly table. And I have made functions. I did a Carta app a long time ago that sorted 100 cards and then sorted 50 cards. And that was very necessary. I couldn't have done a silly table for 100 numbers. That would have been a serious table. But this is easy. It took me less time than actually thinking about how I did the sorting before, the random sorting. So, yeah. And there's no while loop. There's no possibility of it taking a while. There's no overhead. It just references a table, and not an extremely large table either. I don't need to justify this. It's a silly table. So, yeah, the second cut, it goes through the table of valid moves. That's why there's 4 numbers, because every position has 4 other positions that are valid. Just on a very base level, you can move to them as you're moving in the... Wow, I did that really easily. That was actually like exactly the thing. I'm really used to working with this algorithm. Like, so yeah, so it goes through the moves. It goes through the valid moves, and then it applies. In the second cut, it just does it. It says if it's a valid move, do it, because there doesn't need to be any consideration between the first and second move. The first can be anything. The second can be any valid move of the 4 valid moves, and then the third cut is where we start having additional logic that has to consider, like, well, if you're moving back to the same dimension as the first move, that has implications for later moves, and if you don't, that has different implications for other moves. And you can see here, this is actually like the exact opposite. Like, if you move back to the first dimension, you check that these aren't equal, and if you don't, you check that they are equal. So, all of this took me quite some time to, like, formalize a structure of, like, what the valid moves are, what exactly these equations were referencing, because I had these 5 equations. These 5 equations were right, and I was generating something, but it wasn't, there wasn't logic to it. It was just, like, well, these are two random numbers, and I just get two random numbers. Like, there's no difference between these two equations because they're just random numbers times 2. The same possibility of random numbers times 2. But equation 2 and equation 4 are functionally, they're the same, but they can't just be, you can't just have like you need to consider when these describe 2 and 4 and 3 and 4 and 2 and 5 and 3 and 5. Like, they have to be 2 and 4 and 3 and 4 and 2 and 5 and 3 and 5. That's true. You have to use these equations in a certain configuration. It has to be very specific. Just iterating through them doesn't work. It had to be very carefully considered what these describe and what moves they allow. And that's what these tables did. These tables right here, not silly table, these tables are what took 24 hours to come up with, was the structure that made them work to make the algorithm work. And shoot, I think that might be it. I don't know. I can show you my quaternion code. I think that's pretty fun. This is for motion. This is actually. Let me look at the quaternion code really quick. So this quat molt. This is the formula that I came up with. Which exists. I didn't invent it. It existed out there, but I hand calculated it, and I got it wrong. So, and eventually I got it right. But this was already in the thing that I was using. This turns an axis angle into a quaternion, but this was being used as a just like, you take the axis angle and you work with the axis angle, and then you kick that to a quaternion, and then you kick that to the rotation matrix. But then you have your axis angle problem with the Euler angles. I'm doing the rotation, your camera rotation is held inside a quaternion. Like, that is what your orientation is. The orientation is a quaternion. And yeah. So this is the fun part, okay? Because I was saying that it's 6-dimensional because quaternions are 4-dimensional, but it's 4 spatial dimensions. And when you talk about translating or moving based on a quaternion orientation, you get a lot of pushback from mathematicians. When I was looking this up, a lot of my search results were math-based, not game dev based, because mostly people who work with quaternions are mathematicians, and a lot of them were very quick to say, you don't convert a quaternion to an axis angle, because, and it's very clear, if you do it, it's very clear why you don't do it, because you're doing, well, first of all, your angle is derived from a cosine function, so it's going up and down, -1 to 1, up and down, up and down, up and down. And it maps to a positive number from, 0 to 6 radians about. And, as I'm doing this, you can see the problem. You want to go like this, and then you want to continue in the same direction. If you're turning a direction, you want to continue turning in the same direction, not start turning in the opposite direction. And the reason this requires 6-dimensional thinking is because in game dev, essentially we get access to 2 additional time dimensions. One, the time dimension going straight forward, which we all know and love. The time shoots like an arrow. And then a second time dimension, which is considering alternate possibilities. And it is really summarized right here. Just if. The if-then statement is essentially the game dev path to extra time dimension calculations. And you see this in a game like 5D chess. Normally when you play a game, it is a single time dimension, the same as the reality all around us. But games like 5D chess, where you can move freely in a time dimension other than straightforward, is extra dimensionally in the time dimension. So when we're programming, we essentially have access to that time dimension, because we can say, if a missile is going this way, have it turn this way. If it's going this way, have it turn this way. So we're actually, manipulating things in an additional time dimension. So this really just says, it, in a vacuum, if you said, here's a quaternion angle, and here's a quaternion orientation, what's the angle? In a vacuum, it's terrible. It's a terrible way to describe an axis angle. You can't really do it. And that's why there's pushback from mathematicians, because you can't do it in a vacuum. But if you know the circumstances that led to that angle, then you can derive the actual angle. You can figure it out, what the actual angle is. And that's what this function does. And it's, it's got some goofy stuff. It's like it considers if you're turning left and the last time you rotated, you also turned left, then, you're affecting the secret ang, which is used here. The secret ang, basically, there's the angle, and the last angle, these are always, the angle is in this calculation right here. So the angle is called from the quaternion, so that it's always working off of the derived angle. The secret angle takes the angle and it doesn't get held in memory, because we need to remember what's happening to the angle itself. But under the right circumstances, it flips it negative. And if we think about that, let's say you go from 0 to about 6 radians to where you're back where you started, or 360 degrees. Now, if you go a little past that, it could be like 1 degree. Or it could be described as negative 259 degrees, which, if your angle is increasing and then decreasing, that negative 259 describes the same angle that you're trying to get, as though it was, looping back around to 0. So yeah, that's how that works for movement with quaternions. I did find myself wondering as I was going through this, how did the people who made games like Descent and Ace Combat do this? Because they have free motion. You can move in the same ways. You can pitch, yaw, roll. You've got access to all of them in those games. And I'm wondering if they did the same thing, if they did quaternion orientation and then, using the time dimension calculations to, derive an angle for movement. And if so, wow. Because I had that Visualizing Quaternions website, which was great, but that didn't exist back then. The fact that people who barely had access to the internet at all, there barely was an internet. The fact that they were able to do this back then is staggering to me. Maybe there's something I missed about how they handled it, and it's an easier problem, but wow. Whew. All right. Yeah. I think that's it. I think I covered everything I really wanted to talk about. So, yeah, that's my devlog at the point where the jam is not over, and I still want to add some voices, and but it's done. It's really done. Other than the voices, I'm not doing anything else with this project. I'm getting back to work in The Stars in Your Eyes, and I'll be working on the HELL³ soon, and yeah, that's it for now. Thanks for tuning in, and I'll catch you later. Bye.